is Abdul Rahman. I'm a lecturer at a public university in Kenya. I deliver lectures in computing and informatics. In our last lesson, we discussed about memory management outline. We had seen that the outline, it has around 4 segments. We had what you call the code segment, the data segment, the heap segment, and lastly we had what you call up the stack segment. Today we are going actually to start up in another topic whereby we are going to ask a question: what are the memory allocation methods? And onto that particular journey we are going to define what is allocation methods, and then we are going to see what are the types of allocation method, and finally we are going to go to the dev C++ and implement the same. So let us start onto that particular journey, and here we are asking ourselves, what is it all about memory allocation methods? So the memory allocation method actually will depend on 2 items. Will depend on what we had seen others, that it is the type of memory, and the type of memory or the layout of memory. So basically it is actually the layout of memory. We have seen that actually we had the layout of memory, which can be actually according to the data code, or to the code segment, the heap segment, where is it actually taken up. Also it will be according to the type of a variable. So it will depend on the type of a variable, and into our previous video we had seen that there are 2 types of variables, that is the global variable and what you call the local variable. So it will depend onto that. So into that then we'll have 2 types of memory methods, and these 2 types of memory method actually they are the static memory allocation, and we'll have the dynamic memory allocation. So this is what is memory allocation, that there are 2 types, the static and the dynamic. So let's see what each one of them means and what each one of them actually has. So when you come to a static memory allocation, basically we are saying the static memory allocation, it is actually allocated during compilation of a program. Number 2, we are going to say the size of the memory actually remain unchanged throughout the program life. So the size of a static memory, it is actually unchanged throughout the life of a particular program. And when you write up a program, actually it is implemented when we have what you call initialized and uninitialized variables, and also it is also implemented when you have got global, local and static variables. Let's see the dynamic memory. The dynamic memory, as opposed, it is actually allocated during the runtime of a program. So it is allocated during the runtime of a program, The size actually it is flexible. This particular size you can either increase it, decrease it, or you can free it. And actually it is the program, besides being stable, it is implemented using up various data types such as a structure, a pointer, or it can be applied using up an array. So basically these are the two types of memory allocation we had seen so far, and this is what you call the static memory allocation and the dynamic memory allocation. So in order to understand this particular two concepts, so let's go to Dev C++ and implement the same. So in Dev C++, basically we are going to have a function. We are going to have a function. So that particular function, I'll call it double twice salary, and I'll pass on a variable of double type called input. Then from there, to complete up my function, I'll have opening and closing brackets. So inside there, I actually declare a variable called twice, and that particular variable called twice, I'll assign it our input times 2, and then I'll basically print f. I'll just print f that double your salary equals to, then I'll have percentage, I'll have it to 2 decimal since it is a double float, and then basically I'll pass on my variable called twice. So when I go back to the main method, so basically here what I have done, here you have got up a variable, and in this particular variable, actually this particular variable, it will be pushed to a stack. So this is a variable, and this particular variable will be pushed to a stack. So the variable twice will be pushed to stack when the function is called. And out when the function exits. So basically that's what that will happen. This particular variable twice will be pushed to a stack when we start this particular function twice salary, and it will be pushed out from the stack once it is finished to actually execute. So let's go to the second part of it. So here let's declare a few variables. So let's take for example int age equals to 30, and then another one we are saying maybe at the same time double salary equals to, or maybe hypothetically, 4, 5, 3, 2, 1, 3 to 1, 0.34, and then maybe we have another one, double, let's say marks, and this is an array maybe of size 3, and in that particular array we can pass on some few numbers, 34.4, 35.7, and finally maybe 56.7. So that will be our double, and finally here we are going to call up our twice salary. So our twice salary, we are passing on the value of the salary. So what we have done here basically, again, here we'll have we'll have our three variables, that is age, salary. Here we'll have our three variables, age, salary, and marks. Being pushed to stack segment when our function main is executed, and out of the stack when the function exits. So basically what happens is very simple. When the function main it is called, we have got age, which has been initialized and given a value of 30, and salary and marks, all of them will be pushed to a stack actually to do the calculation. Once they are out, then they are pushed out on this particular program. And here also our twice salary program, when it is called, it will get out and move here and actually push twice into a stack, and when it finishes, actually it exits. So this is basically how you demonstrate actually memory allocation method using up a static method. So let us run this particular program and see the result. So when we run this particular program, we are seeing actually it took up 0.112 seconds to run, and it says you double your salary. Actually, when we passed on the values 5, 4, 3 to 1, and it's double 10, 86, and actually giving us into 2 decimal places. So we have demonstrated what actually are the memory allocation method, and into our next lesson we are going to take up the second part, what is the dynamic memory allocation. So thank you all for listening. However, don't forget to subscribe into our next lesson. For now, I say bye.